Okay, so now we are starting a new chapter. It only has, I think, day 3. So I'm hoping we'll be done in like 2 weeks, 2.5. All right, we got short weeks coming up. All right, so put your name on it. All right. So this whole unit is on graphing, and all the graphs are look kind of very similar, right? So of something called linear relations, right? Linear means a line, so all our graphs will look like a straight line, right? If it doesn't look like a straight line, chances are you're making a mistake, right? And relations means relationship, right? So you're comparing two things, and the relationship is going to be a straight line. All right. Now, first part of the day is going to be hopefully a review from grade 7, grade 6. And I'm going to sort of maybe put a little twist on it. Maybe some of your other teachers didn't emphasize certain things. All right? Now. Shh. Okay. So we have a graph. We have 2 axes. We have one that goes up and down, one that goes left and right. Right? We typically give them letters X and Y. They have to go on a particular line. Which one's X? Which one's Y? Who knows?
No yelling at me.
Yes, Ariana, which way is X?
X is
This.
horizontal. Incorrect.
Yeah, so X is this way. Oops. This way, let's use this one. I'm going to put the letter X here. And Y is this way. And my students, doesn't matter which grade I've taught, all up to grade 11, grade 12, they always get these confused, right? Nobody ever remembers them. And this is my technique, which I teach to my students, and usually it works, right? This is how students tell them how to remember this. Think of Y as yes, X as no or wrong. So when we say yes, we typically go like this with our head, up and down. That's the Y axis. When we say no, we go this way, X, left and right. Make sense? All right? So to help remember which way is which way, right? If you're one of the few people, many people actually that forget it, right? Yes, up and down, no, left and right, X. Simple as that. So now, when we have graphs, we need to be able to read the values off of them, right? So we have a set of points here. For example, here. And we want to know what are the X values and Y values. So what is the X value for this point here that I highlighted in blue? How do you read that? What's the X value for that?
5.
It is not 5.
10. 12.
We go from the dot down to the x-axis. The X value is 1 from this point. Okay, now our table can look like this. There's 2 ways we can draw tables. We can have a horizontal table like this or a vertical table like this, right? That's the 2 main ways we draw tables. And we'll talk about how to create these tables in a second. So here, if I want to record the value of 1, do I put it on the top here or on the bottom here? One says radius of circle, one says diameter circle. Where does that 1 go? The top one, because here, X is radius. It says that on the graph here, so we're going to put 1 here. Now, what is the Y value of this point? 2. So we go from here across, that goes there, 1, 2. All right, so I'm going to go over here, I'm going to transfer that information. We said the radius of the circle is 1, and we said the diameter is 2. Okay, then we go this way. Next point, let's do it in green. What's the x value? What's the y value?
2 and 4.
Thank you. 2 and 4. So in green, x is 2 and 4. 2 and 4. Okay, next one. I'll do it in orange. What's the x and y values here?
3 and 6.
Thank you. 3 and 6. 3 and 6. And finally, am I out of colors? Oh, no, I'll do this one in yellow here.
4.
Yep, 4 going down to here, 4 here, going across this way, 8. Yes, Alice, you want to do the next one?
I was gonna say that this one has a pattern.
Oh,
Top numbers, the bottoms are doubles.
yeah, good. Keep that in mind. We're going to talk about that in a moment. Okay, so now here I gave tables for you to fill out. But there'll be situations where I'll give you the graph and you need to create the table yourself, right? So the table is either going to look like this, or, so that's the vertical one, or it's going to look like this, the horizontal one. And you have your little lines going like this. How do you know what information goes into what column? Because it makes a difference. You can't just mixy-matchy. It goes a certain way. Yes?
No, there's something else. Can't you just do like bracket, number, comma, number, bracket?
That's a different way. That's coordinates. We'll talk about that as well. All right? So if we want to make a table, here, in the horizontal one, I put radius on the top. It's supposed to be on the top. Right? How do you know which one goes on the top? Max?
Is it just always X on top?
Always X on top. Okay? X is always on the top in a horizontal one. So, right? If you look at this one, a vertical column one, which one's on the left? Is it the X or is it the Y? Alice?
X.
X. So X comes first each time. All right, so we go X here, that means this is Y here and Y here. And whatever the name of X is, and whatever the name is Y. We don't use X and Y unless it's X and Y. Here we write down the names. All right? So we say the top row or the left column, depending on the table we have, right, is always your horizontal, which is your X axis, right? Top row, right? Then for the other one, the second row, or the right column, is your vertical, which is your Y. Right? Now, how to remember this? Because that's something really easy to forget. What I tell my students, which works with most of the ones, is I can say, think of it in alphabetical order, right? X comes before Y. We read from left to right, so X can come here, then Y can go there. When we read a page, we go from top to bottom, alphabetical order, X before Y. I'm not sure if that's going to help you. That's my little trick to help students. Like with all these things as you grow up, like there's a lot of things you can be asked to memorize. Your teachers will give you tips. If those tips don't work, you got to figure out your own little technique to help memorize these things. So I think that usually works for most of my kids. Like, hey, X, then Y, alphabetical. Same way we read a page, right? We go from left to right, top to bottom, right? Okay. All right, now. Here's the relationship part next, is you're used to reading values off of a graph. But the graph is only a picture of a certain area of this relationship. This relationship continues on forever, right? So a question may ask you to find you a value that's not inside this graph. For example, what is the diameter of a circle that has a radius of 8? Right? And we can't do that because if you look here, off this graph, radius of 8 is not there. But Sam,
16.
and how do we know that?
8 times 2.
8 times 2. And Alice, what did you notice?
That the radius is half of the diameter.
So, or multiply by 2.
Yeah.
Right? So Alice noticed this and Sam noticed this, that the relationship between these two is that one's double the other or half of the other, however you want to look of it. So if I ask you for a value that you can't read off the graph, but you know the relationship, you can still figure it out. Right? So we're saying, hey, it's double, so our diameter is going to be 8 times 2. It's going to be 16 centimeters. Okay. So next up is here. What is the radius of a circle that has a diameter of 22? Yes, Alice.
11 centimeters.
11, and how did you get that?
Because it's half of 22.
Half of 22. Once again, we can't read it off this graph, right? But we know it's a 2 relationship. So our radius is 22 divided by 2, and which is equal to 11 centimeters. Okay. So now, students find the next question annoying, right? You can come across a lot of these questions. I'm going to read it out first. Is it reasonable to include a point on the graph for 4.5 centimeters? Alice?
No, because you can estimate where the point
Okay, that's your thought. And I saw another hand up over here. Sam?
No.
You say no as well?
Yeah.
How come? What's your reasoning? That's what your gut says?
Yeah.
Right? So now, here's the thing. And up to now, a lot of your math has been whole numbers. And whenever you see a decimal as the answer, you think you made a mistake.
No.
Right? Well, that's why a lot of students see it as that. But decimals exist as part of numbers. And you can have them in certain situations. Right? Now, this question is about this relationship. And that's what all these relationship questions can be about, this relationship. Can this exist?
Yeah.
Can you create a circle with 4.5
Yes.
centimeters, right? So then why not be able to put a dot at 4.5, which would be right here. It would fit right in there. And then you could read off the value of the diameter of 9. So it's completely reasonable because yes, you can have a circle with that property, with 4.5 centimeters. Right? So you'll, yes, because we can have a circle with a radius of 4.5. Right? So you just got to put it into context. Can this exist? Okay. So now, I'm going to, where is that other question? While we're still talking about that. Okay. I'm going to jump. I'm going to ask you to jump here to this question here. Okay. So now, this question, we're not going to do all of it now. We're going to do the very last question of it. It's saying, okay, this is the cost for how many ever posters you have. Okay? So I'm going to go to the very last question. This is interconnected to what we're talking about right here. It says, is it reasonable to put a point in between these graphs? So it's asking, hey, for this graph, can I put a point here, or a point here, or a point there? Is that a reasonable thing to do? Yes, Sam. No. And why is it no this time?
It's not a line.
It doesn't have to be on a line, right? So you can. It's no for a different reason. Your answer is right, but not for that reason. Yes.
Because the numbers aren't matching up.
No, like, so that's the thing we're gonna get from grade 6 and grade 7, where all the numbers always fell in perfect crosshairs. That doesn't happen anymore. It's nice, but you're gonna learn how to estimate and draw points. Alice?
Because you can't have half of a poster.
Yeah, so if I put it here, and you read this value, you can't have half a poster. Where you could have had a radius of 4.5, that makes, for a circle, that makes sense. But you can't go by half a poster, right? All right, so here, we're going to say no, because you cannot buy half a poster. And that's where these kind of questions are going to come into place. Like, you can just put it into the real world situation, like, does it make sense? Can you actually have a, it's going to be all the same thing. Can you have a whole version of this, and can you have a decimal version of this? You can, right? You can buy whole posters, but you can't buy partial posters, right? All right, so my last question, then I'll give you guys a break. We're going to finish off the first page. Okay. So, yes.
What about a pie? Like if you're buying a pie.
Well,
Yeah.
you can buy,
Probably not going to buy half a pie.
there are places that sell half a pie.
Though, yeah, some places you might buy
Yeah.
like a slice.
And you can even go to the grocery store nowadays and buy half a watermelon because you think a watermelon's too big. You can go buy a half a watermelon or a quarter of a watermelon. So it really depends on the situation, right? Okay, so now, the next question, not too hard. We're just reading some values off of it, right? When we are drawing lines, technically, you only need 2 points to be able to draw a straight line, right? I suggest to my students to always pick at least 3 points, because that way if you made one of the mistake on one of the points, it's really easy to tell where you made the mistake. But if you pick 4 points, that means you can tell where you made the mistake on. For example, if I draw these 2 things, you can draw a straight line up through there, right? But you don't know if any of these points are right or wrong. But if I put another point here, and you know the picture is supposed to be a straight line, you know something's wrong. But you can't tell me what's wrong. But with a 4th point, so if I put in a 4th point, let's say I put it in here, you can probably tell me, hey, which data point did you probably draw wrong, right? Which one is it?
The second black one.
The second black one, right? Because everything else fits the line here, right? So when you're drawing a line or coming up with stuff, I say come up with 3 points. Technically, you can get away with 2, at least 3, 4 is best, all right? So here, we're going to read off 4 points, okay? So we're going to make a table and come up with 4 points. And I'm going to do a vertical table, okay? So if I have a vertical table, I need to label the table. On the left side, am I going to put distance or am I going to put time? Time. We put x first, right? So this is our x-axis here, our horizontal one. So we're going to put time here. And we're going to include the units. We'll put in h for hours, right? That means distance goes over here, and we'll put in miles. Okay, so now we need to read off points. Now if you look at this, all right, some of them are really nice to read off. For example, this one would probably be a nice one to read off with. And this one's going to be a nice one to read off of. All right, because they fall exactly on numbers on both sides, but that only gives us 2 points. Yes?
1.5.
How about 1.5? That'll be right here. We can do that one there, and we need another one. Yes, Sam?
0.5.
0.5. We'll do that right here. So Sam suggested 0.5 here. So what would be the matching distance here? 25, right? And 1 here, the matching distance would be 50. Right? Then we have 1.5 here. And the matching distance for that would be 75. Right? And finally, 2 and 100. Yeah, that's it. Okay, so we'll stop right there.